Question number 4, suppose secant of theta equals 4. Determine the exact values of the other trig ratios between 0 and 180 degrees. Well, first of all, if secant of theta equals 4, using the shortcut we just talked about, I know what cos of theta is. I know that cos of theta, being the reciprocal, would be 1 over 4. Where is theta? Your cast rule tells you where theta could be. And cos theta being 1/4 tells us that cos of theta is positive. Our cast rule tells us where trig functions are positive. So this right away would tell us, well, all of them are positive in quadrant 1, and cos is positive in quadrant 4. But for part A, do you see that part A says only look between 0 and 180 degrees? So we would only look in quadrant 1. I like to draw my 4 quadrants. I like to draw my angle in the quadrant it's supposed to be. So here's theta. And I like to make a right angled triangle to the nearest x-axis as a result. Can you see in quadrant 1 that your theta is also your reference angle? But usually when you, in any of the other quadrants, when I draw the line back to the nearest x-axis, the angle in that triangle will be the reference angle. In quadrant 1, it happens to also be the regular angle. Now, I know that cos of theta is 1 over 4, so on this triangle, I could label my adjacent side as 1, my hypotenuse is 4. That's one possible triangle. And if I use that as a possible triangle, again, you're going to get really good at a squared plus b squared equals c squared. You can figure out this other side. But it's not 17 this time. What is it? 50. Right? Because you know the hypotenuse. So you'd have to do 16 minus 1 squared to get 50. Good. So now that we have the triangle, can you see that you could easily figure out sine theta as being opposite over hypotenuse? It would be positive because it's in quadrant 1. And if you know sine theta, you could write cosecant theta. And you could easily write tan theta, opposite over adjacent. And as a result, you could write cotangent theta. Now for part B, now they're saying find what theta is, but instead of just looking from 0 to 180, go all the way from negative 360 to 360. Will that now include quadrant 4? Yes. So I'm going to draw a picture. I'm going to redraw the 1 in quadrant 1. And I'm also going to draw the same angle in quadrant 4. So on both of them, this is technically my reference angle. And both of them I draw a triangle back to the nearest x-axis. And we already figured out that this was 1, this was 4, this is root 15. It'll be the same here. This is 1, this is 4, this is root 15. And we need to figure out all of the angles from negative 360 to 360. negative angles go backwards, positive angles go forwards. Like one goes counterclockwise, one goes clockwise. Okay? So as an idea, and I'll always, let me just write this out. This is what I think. I think positive angles 0 to 360, negative angles, I'm going to write it this way. It's different than our domain, right? If I would do domain, I always write the smaller number first to the bigger number. But when I'm thinking about angles in standard position always start at 0. So my positive angles, which I'm going to do in blue here, they're going to look like this. Here's one positive angle would get me from 0 to that one. And if I wanted the positive angle here, I'd start at 0 and go to this direction. The negative angles, I'm just going to show in red. The negative angles also start at 0, but it would go all the way around to there in this one. And in this one, it would look like this. So those are the 4 angles we need to find to solve this question. And to go about that, we need to first find the reference angle. How do we find the reference angle? We use the actual triangle and the numbers on the triangle and set up an equation. In this case, I would still use cos because it doesn't use the square root. But it doesn't matter, you could have used sine or tangent. So cos of my reference angle is 1/4. And so my reference angle will be cos inverse, on my calculator, cos inverse of 1 divided by 4, push enter, and I get, oh, I'm in radians. Turn my calculator in degrees. 75.522. Degrees. If you're dealing in degrees and you don't write the degrees sign, that's a units error, and it will show up as an E5. So if you forget your units, that'll be an E5. If this is 75.522, what does it ask us to round to in this question? To the nearest degree. Okay? I'm going to go back to my diagrams. Are you okay? Was it 75.5? So it would round to nearest degree. Would you agree that that one's 76? If I wanted to do coterminal backwards, okay? Again, this is, I think of negative angles with positive numbers first. Would you agree all the way around is 360? So I would go, from here to here would be 360 minus 76, and whatever answer I get, I'll just make it negative. So 360 minus 76, that's going to give me, what is that, 284 degrees? So this is negative 284 degrees. If my reference angle is 76, does this red one make sense to be negative 76? And if all the way around is 360 degrees, and I subtract 76, then this will be positive 284 degrees. So when we go to write our final answers here, theta equals 76 degrees, 284 degrees, negative 76 degrees, and negative 284 degrees. AP Calculus, when you get a final answer, they like you to put a box around it, so it's good practice for us to do that already. Questions for practice on this one are 9, 10, and 11.